Good day everyone, today I'll present to you general familiarization of Airbus A320 and Boeing 737. In aviation, GenFam or general familiarization is the foundational and technical training course. It is often part of
In aviation education, students are required to understand complex aircraft structures such as the Airbus A320 and Boeing 737. However, learning is still largely based on manuals, diagrams, and two-dimensional images. While these materials provide important information, they place a heavy cognitive load on learners. Students must mentally convert flat images into three-dimensional structures, which requires additional effort and can lead to confusion and reduced comprehension and lower retention. This challenge becomes more evident when studying how aircraft components are arranged and how systems interact as 2D representations do not fully support spatial understanding.
This is where Aerogram comes in. Aerogram is a 3D interactive holographic display designed to enhance aircraft familiarization for complex models such as the Airbus A320 and Boeing 737. By combining holographic visualization, gesture-based control, and touch interaction, the system allows students to explore aircraft components in a more natural, intuitive, and immersive way. Instead of relying on flat images, students can view structures in three dimensions, observe how components are arranged, and understand how systems function together as the complete aircraft. The integration of interactive controls also allows users to actively engage with the model, making the learning process more dynamic and effective.
Aerogram is a 3D interactive holographic display designed for aircraft familiarization, featuring the Airbus A320 and Boeing 737. It combines holographic projection, gesture-based control, and touchscreen interaction to create more immersive and intuitive learning experience. Through interactive 3D visualization, students can explore aircraft components more clearly and understand how systems work together in real time. The system is evaluated using imaging quality standards based on ISO/TC42, ensuring high-quality visuals in terms of clarity, color accuracy, depth perception, and overall viewing experience.
The project also supports several sustainable development goals, particularly SDG 4, quality education, by introducing an interactive learning tool that helps students better understand aircraft structures. SDG 8, decent work and economic growth, by helping aviation students develop technical knowledge relevant to their future careers, and most importantly, SDG 9, industry, innovation, and infrastructure, by demonstrating how emerging technologies like holographic visualization and gesture-based interaction can be applied in modern educational environments.
The primary users of Aerogram are avionics students of WCC Aeronautical and Technological College, Binalonan Campus. These students are trained to understand aircraft electrical, electronic, and integrated systems. Because these systems are distributed throughout different parts of the aircraft, it is important for them to first recognize the components located within the aircraft structure.
Aerogram is designed as a self-contained interactive kiosk that integrates several hardware components into a single system. At the top of the device is the holographic projection structure, composed of transparent acrylic panels arranged in a pyramid configuration. These panels reflect images generated inside the system to create the holographic projection.
The holographic projection in Aerogram is produced using a modified Pepper's Ghost technique, an optical illusion that creates floating images through controlled reflection. The aircraft model is rendered on the internal display and reflected onto the angled acrylic surfaces above it.
The system is operated through the touchscreen interface, which serves as the primary control panel of Aerogram. From this screen, users can select aircraft components through interactive components options displayed on the aircraft model. When a component is selected, a written description appears on the screen explaining its function.
Aerogram uses a camera-based system to detect your hands. To activate gesture control, simply raise your hand in front of the camera. On the touchscreen, A live camera preview appears in the upper right corner, helping you check if your hands is within the frame. The system can detect your hands within a range of up to 2 meters. Once detected, visual indicators will appear on the hologram. Red for the left hand, blue for the right hand. Circle for open palm, square for closed palm. When these indicators appear, gesture mode is active.
Once gesture mode is active, you can control the aircraft or selected component using hand movements. Use one closed fist to rotate left or right and tilt up or down. Move both closed fists outward to zoom in. Move both closed fists inward to zoom out. Show an open palm to keep the view steady. As long as the indicators remains visible and your hands are within the camera frame, the system will respond to your gestures in real time.
Aerogram currently includes two aircraft models, the Airbus A320 and the Boeing 737. Through the system, user can explore the structures of both aircraft and observe similarities and their differences in their design.
The aircraft models contain multiple interactive parts representing major aircraft components, such as the nose, fuselage, wings, engines, landing gear, and tail structures.
For aircraft lighting components such as navigation lights, landing lights, taxi lights, beacon lights, and strobe lights, the system behaves differently. Instead of isolating the component, the selected light is illuminated on the aircraft model, allowing users to visualize how these lights appear during aircraft operations.
When a component is selected, the system displays written information describing its function. Users may also play an audio narration paired with subtitles. The audio explanation can be replayed at any time, allowing users to review the information whenever needed.
Aerogram is designed as a supplementary instructional system that can be integrated into existing aviation training environments. The system may be used during classroom discussions, laboratory sessions, or guided demonstrations, allowing instructors to incorporate it as part of their teaching process.
Before conducting the student's evaluation, the Aerogram system was first tested and reviewed by subject matter experts. The experts examined the system's features and provided recommendations to further improve its functionality and effectiveness. After incorporating these insights, avionics students were then given the opportunity to interact with the system and explore the aircraft models. Following the demonstration, the students complete evaluation questionnaires to provide feedback on their experience with the Aerogram.
The evaluation results for Aerogram indicate a strong overall performance across all technical criteria, with each category maintaining an average weighted mean above 4.10. The system achieved its highest rating in maintainability with a mean of 4.23, followed closely by functional suitability and security, which both earned a 4.22. Flexibility also reached the highly category with a mean of 4.21, while reliability was rated at 4.20. The remaining categories fall within the moderate range, including interaction capability at 4.18, safety at 4.17, and performance efficiency at 4.16. Together, these scores position the holographic display as a highly functional and adaptable tool for aviation training.
Aerogram demonstrates how interactive holographic technology can transform aviation learning.
Instead of relying solely on field exposure to large aircraft, students can now explore these complex machines at the palm of their hands.
Aerogram creates a new way of learners to observe aircraft structures and understand how modern aircraft systems are organized and operate.
Aerogram, making aircraft familiarization more accessible than ever.